Welcome to Education at SSBJ, online video tutorials. And here we are to continue the previous chapter which we had started in the first video lesson of this chapter, Force and Pressure of class 8th. Dear children, before we start, we shall recall what all we have studied. Right? Now, what all we have studied? We studied the definition of force. Now, we'll recall what is the definition of force? Simple. Force is a pull or push, because every action in day-to-day life involves either pull or push, and that is what is force. And when we apply force, what happens? How does force affects an object? The object which is at rest or object which is moving already. So we had studied the effects of force, and in that we had seen if the object is at rest, and what does object at rest mean? The one which doesn't move, an object which has speed 0. And on this object, if you apply force, then that object tends to move. Object moves from position 1 to position 2. And who did that? It's an application of force, right? So when the force is applied, force can tend to change the position of the object. If you apply it on a moving body, right? Suppose in this case, if you apply with more force, and here you can see it will change the speed of the object. Now the next one is, if a body is moving in a particular direction, let's say a ball has come towards the cricket player, and the player goes onto the front foot and then swings his bat in such a way that the direction of the ball changes and it goes in a different direction, not in the previous direction where it was supposed to go. Which means force can change the direction of the moving body. The next one is, if you apply force on some bodies, a force even tends to change, what do we say? Shape of the body. So force is pull or push. Force can change the state of the body. That is, force will change the position of the body, make the body to move faster, change the direction of the moving body, and force can change the shape of the body. Now, this force, which is a physical quantity, just like, length, time, weight, right? We measure length, we measure weight, and we also measure force. But when we measure force, how do we express? We require a unit for it, right? But wait a minute. Unit? What is that unit? Well, suppose, consider that you have drawn a line and you don't know the exact length of this line. I repeat, length. Length is a physical quantity. Suppose if you want to measure this length of a line, what do? We have to take a scale, and then we keep the scale just beside the line and see both the ends. It starts from 0 to 15, and we say that, okay, the length is, how much? 15. But some problem. 15 what? "15 centimeter" is the right answer. Right? So 15 centimeter. And what is that centimeter? Centimeter is the unit of length. What are we measuring here? Length. And length is expressed in centimeter. And length or a distance, both are same, They are expressed either in centimeters or meters or kilometers, and so many other units are there. We'll study in detail. This is just for an example. You tell me now, suppose if you want to measure the time. Here you measured the length. Suppose if you want to measure the time. Now what's the unit? We use second. But is it only the second? We use minute. Is it over? No, we use hour sometimes. We use days. We use year. Right? So one physical quantity can have many units. Right? You are getting clear what unit is. Right? Don't get mixed up with physical quantity and unit. Physical quantity is time, and unit is either second, minute, hour, days and year. Right? Now one more physical quantity we'll take up now. Speed. Speed is a physical quantity. And what is the unit here? Kilometer per hour. But is it only kilometer per hour? Meter per second also. So now we have seen here few examples of physical quantities and their units. But actually we started with the physical quantity called force, pull or push. Right? And we should know the unit of the force, because force is a physical quantity which is measurable. And so what is the unit of force? The unit of force is Newton. Remember this? Symbol is N. And it is a standard unit of force. We have already studied what is standard unit. Let me not explain here in this unit. Now why is this Newton is taken as a unit of force? Remember, unit of force is Newton. It is named after Sir Isaac Newton. You can see photograph here because of his great work on classical mechanics. So much of work he has done, discovered gravitation and many more. Right? A genius. So in respect of him, Newton is taken as a unit of force. So whenever we use and measure force and refer force, we are, giving a kind of respect to this great man, Sir Isaac Newton, because we have to refer his name. Right? Now, how much is the force? Right? See, we all know that in one way or the other we apply force. You can see Muhammad Ali, a great boxer here. Now when he is boxing, he is applying a force. So we should have an idea of how much force, It is said that this great man, a champion of boxing, applies for his one punch 350 pounds of force. 350 pounds? But we have heard the unit of force is Newton. Yes, you are correct. We'll convert this 350 pound force into Newton, which is equal to almost 1556.9 newtons. Oh my God. Can you imagine one punch and 1500 and odd newtons of force? Okay, we'll compare this. One cylinder of 14 kg, LPG cylinder, right? And how much of force it exerts on ground? 137 newtons. You compare this with the force of one punch. It's very difficult to lift a cylinder because it's 137 newtons. And now you see this 1556 newtons in one punch, right? This I have given an example just to understand the magnitude of force, right? The force has magnitude and force also has direction. These things you will learn in next class, in class 9th, right, in detail. But here you should remember the basics of force. Force is pull or push and it is measured in newtons. Now, force is categorized, right? The first category of force is contact force. Contact force. And what is that contact force? What does it mean? You can see here this football player applying force right on football. But if he swings and kicks his leg or a foot just in the air, can the football move? No, he has to have a contact. Look at this man. If he wants to play this ball in some other direction, he should have a contact. The force that requires contact to occur. When you are playing billiards, we have to have a contact. So in all these examples, we have observed that in this case we require contact, otherwise the ball will not move. Tug of war, you have to pull actually with the help of muscle, right? All these are contact forces. So what is contact force? The force which requires contact to occur. I repeat, the force which requires contact to occur is called contact force. And muscular force, anything we directly apply using our muscle. Okay, he is using his muscle. Okay, muscle is being used. Muscle is used here in this example. So in all this example, muscle is used. We also in our school, in every action we use body muscles. Like in this example, you can see some of your seniors pulling a rope. In fact, pulling people on opposite direction here, who are there in opposite direction, what is used? Muscular force. And that is a contact force because it requires contact to occur. Now let us have one more example of the contact force, right? So understand this very clearly. You can take a pause in between, right? Recall all which is taught already. Just apply a pause here in this video. And now next you are going to learn is about some force, which in detail you will learn in separate chapter. But in this chapter I'll give you a brief thing. Right? Try to understand this now. Right? You can see here. Right? These people are going somewhere, you know. A vehicle is moving front. And who pushes that vehicle to go front? It's an engine. Right? So this vehicle moves on engine support. There is an engine inside. Machine is there. Fuel is supported. Right? But sometimes what happens? The rough road reduces the speed. He wants to go in more speed, but he can't because of the rough road. But wait a minute. We have seen in the previous class, that is previous video lesson, that you can reduce the speed of the motion. And how can we reduce? By applying force in an opposite direction, isn't it? Now here speed is reduced because of the rough road, which means there is some force which is acting in an opposite direction other than a force applied by the engine. Force applied by the engine is making the vehicle to move front, but there is some other force which is avoiding the speed there. And what is that? Rough road reduces the speed because of the friction. You can see the friction is between the tire and the surface of the road. More rough the surface, more friction. The friction between tire and road. And therefore remember, this friction is in opposite direction, because motion is front and the friction is opposite to the motion. Right? So we have to understand, it is the friction which reduces the force. And do you know what is friction? Friction is force. And friction happens when the body is in contact, otherwise friction doesn't happen. When the tire and the floor is in contact, then the friction comes into play. So friction is a force which is a contact force. Right? Right. So what did we study now in this class? One of the type of force which is contact force. Right? So we started with unit of force, and then effects of force, and then the contact force. So in the contact force, we have understood what is a friction force. Right? That is very important. What you have to do now is to take down in between all that what you have understood, write in your own sentence. Writing what you have heard in your own sentence is more important. Right? We will be providing detailed notes on every chapter, but you writing after listening is very important. Have a pause in between 2-3 times. We'll see you again with a continuation of this chapter. Thank you. Be strong, be healthy.